Hello everyone. Uh, this is a lecture on quantum mechanics where we'll be solving numerical problems. Okay. These questions will be coming from angular momentum chapter. All right. Okay. So let's start. Okay. This question is see this is the question number one. Question number one. So that sorry. So that del jx del jy is equal to h squared square j over to j plus 1 minus m square all divided by 2 where del jx is equal to this much and the same for del jy. Okay, so we have to prove it here. All right, we have to prove what? We have to prove del jx into del jy is equal to h cut square whole into j over into j plus 1 minus m square whole divided by 2. Okay, first of all, what is del jx? What is del jx? Del jx is what? Del jx is, it's given here also, jx square minus jx average whole square. Right. So del Jy also the same kind of thing. So if you can calculate del Jx and we'll just substitute the same kind of thing here in del Jy. All right. So first of all, del J like expectation value of Jx is 0. If you know, okay, expectation value of Jx is equal to expectation value of Jy. If you calculate, it will always be what? 0, right? Okay. How do you calculate it? We know Jx is equal to what? We know Jx is equal to 1 by 2, okay, 1 by 2 j plus j minus, okay, this is your Jx. All right, Jx is equal to 1 by 2 j plus, I'm sorry, plus j minus. Okay, jy is equal to what? Jy is equal to 1 by 2i, 1 divided by 2i jx, sorry, j plus minus j minus. All right. So these two are your jx and j minus. So if I put, see, how do I prove that expectation value of jx is 0? So expectation value of jx would be what? Is equal to half. Okay, is equal to half. I can write like this. This is j comma m. Okay, j plus j plus j comma m, right? And it will be what? See, this is your what? This is your ladder operator. That means j plus is your ladder operator. That means it will increase the value of m by 1, isn't it? It will increase the value of m by 1. So I can write it as, okay, sorry, I have missed the negative one. Plus, sorry, plus also half half jm, half jm, j minus jm, right? So what will happen now? See, this is a ladder over this plus will increase the value of m by 1 and this minus will decrease the value of m by 1. Okay. What are the eigenvalues of j plus j minus? If you know j plus j minus, eigenvalues are what? Eigenvalues are is equal to j plus is equal to h cut square, sorry, h cut j minus m, okay, j minus m whole into j plus m, j plus m plus 1, okay, plus 1, and whatever there is, for example, this is here, sorry, this is jm here, jm. If this is jm here, m value will be increased by 1, okay, j m plus 1, right? So here if we put everything and solve, try to solve, you will get what? expectation of value of jx is equal to 0, right? The same can be done for expectation value of jy. Expectation value of jy, that will be also equal to what? 0. All right. Yeah. Now for jx square, jy square, we have to calculate jx square, and jy square. We have to calculate jx square and jy square. Okay. Jx square will be what? Just the square of it. 1 by 4. But this one is what? J plus square. So j plus j minus whole square. All right. Okay. So how do we do it? Just open the bracket. Just open the bracket. Just a second. Let me. To be easier here. Okay. See, j plus sorry jx square, right, is equal to what? Or 1 by 4. 1 by 4 j plus j minus whole square. 1 by 4 j plus j minus whole square. That will be what? That will be 1 by 4 j plus square. 1 by 4 j plus square plus j minus. I cannot write directly that j 2j plus j minus 1 like that, a plus b whole square. I cannot do that here. Okay. J minus j plus. Why I cannot do that? Please let me know in the comment section. J minus square. Alright. So like this thing will also be there. Okay. Alright. Exactly same goes for the jy square. Right. Yeah. So now what? See, one thing will be there. Again, j plus square will be 0 is equal to j minus square is equal to 0. Why? Why like this? Why? Because see, j plus means what? What does j plus do? For example, sorry, this is your j, this is your m. Okay, what does j plus this ladder operator do? It just forget the eigenvalue. It what does it do? It increases the value of m by 1. Okay, m plus 1. If I put j plus square, if I put j plus square again, it will be what? It will be what? J m plus 2, isn't it? M plus 1 plus 1. So j m plus 2. Alright. So m plus 2, there will be jm here. For example, I write jm here. Okay, jm here like this. So jm will be here. Some jm plus 2. Isn't it 0? Because this is not matching, right? This m, this is m plus 2. How can it be 1 or anything? It will be 0, right? So j plus square expectation value is 0. J minus square expectation value is 0. Alright. Okay. Now what we are left with, this is 0. Okay. And this is a 0. So what are we left with? This 2. So jx square expectation value will be 1 by 4 j plus j minus plus j minus j plus. Okay. All right. Yeah. This is also the same for jy square if you calculate. Okay. jy square. Okay. Yeah. Now what? See, there is another thing. Jx square isn't jx square plus jy square. So jx square, jy square, isn't it j square? Can I write like this? J square minus jz square, isn't it? How? Simple. Simple. Jx square plus jy square plus jz square is equal to how much? Is equal to j square, whole j square, right? So I just took z square is to the other side, isn't it? And just put the that expectation value thing. Okay. So this one is this. All right. Yeah. Okay. So see, jx square plus jy square is equal to j square minus jz square. Okay. And we know jx square expectation value is equal to jy square expectation value. So I can put it here in place of jx square will be jx square expectation value plus in place of jy square I can put jx square, isn't it? Why? Because these two are same. Okay, these two are same. So I just put it here. jx square jx square is equal to j square minus jz square minus jz square. Okay, so this becomes 2j x square expectation value is equal to j square j square minus jz square. Okay. Yeah. So if I take this 2 to the other side, it will become jx square expectation value is equal to half of half of j square minus jz square. Okay, minus jz square. All right, is it clear? Okay, now what? Now we know that j square is equal to what? What is the eigenvalue of j square? H cut square by 2 h cut square by 2 j whole into j plus 1 is the eigenvalue of what? J square. Expectation value of j square. Okay, can you remember this one? Okay, and also what is the eigenvalue of jz square expectation value? Jz square expectation value is equal to how much? How much? M square h cut square by 2, isn't it? Because jz expectation, jz eigenvalue is mh cut, right? Mh cut, right? So jz square will be m square h cut square by 2. All right. Okay, I'm sorry. Wait. jz. Okay, jz is what? Mh cut only, na? This by 1 by 2. Sorry. This 1 by 2 comes from here. Okay. Leave it. jz is equal to how much? Mh cut, isn't it? Mh cut. So I will put mh cut here. And j square is out. H cut square, jj plus 1. I'll put it here. And the whole thing will become what? Let's see. Let's write it down. The whole jx square expectation value will become what? 1 by 2 was outside. Okay, 1 by 2 was outside. J, sorry, h cut square by 2 was outside. H cut square by 2 was outside. J, j plus 1, j, j plus 1 minus m square. Okay, m square minus m square. All right. So this is your what? This one, which is also equal to what? Which is also equal to jy square. Okay. Now what? What was the question? What was the question? Let me go to the question. See, this was the question. Okay, we had to prove del x into del jy is equal to this much. Okay, see now, see here, del jx is equal to what? Root over of jx square expectation value minus expectation value of jx whole square. This one to become 0. This one is there, right? But root over is there. Exactly, there was del jy also, and how much it will be? Root over of this one, right? So our question is in the left hand side. Our question is what? Del jx into del jy, right? So I will just multiply both of them. So it will be root over of jx square expectation value into root over of jy square expectation value. Okay. So jx square jy square are same. Okay. So the root over will go away. Like this is same. So this is also become jx. So the whole answer will be what? Jx square expectation value. Okay. And this will be equal to how much? Whatever we got. H cut square by 2. You got this one. This one is the answer. H cut square by 2. Okay. J whole into j plus 1. J whole into j plus 1 minus m square. Okay. This is the answer. This is the answer for what? Del jx into del j y. All right. This is the answer. Yeah. So this is the first question. Like the first beat of the first question only. Okay. This is only the first beat. What is the second beat? What is the second? So that this relation is consistent with del jx into del jy greater than equal to h cut by 2 del j sorry jz expectation value and just a second. Hello. Hmm. Okay. So del jx into del jy greater than equal to h cut by 2 jz expectation value mod. Okay, is equal to mh cut square by 2. All right. So how to prove this one? There is nothing much to prove. You just show that. See what will you show here? First, you read the question. Go back and read the question again, and you can come back. See, see. So since this is the bit B, right? Since what? J is always greater than equal to M, isn't it? J should always be greater than equal to M. Because why? Because if J is, suppose J is a 1, what are the MJ values? What are the MJ values? MJ values are what? Minus 1, 0, and 1. You know it, right? Minus 1, 0, 1. Because it will be minus j plus 1. Right? It will go on like that. Minus 1, 0, 1. So it is always greater than or equal to M. Right? So we have what? We have j whole into j plus 1 minus m square, isn't it? Which is also what? Which is greater than, which we can say greater than m whole into m plus 1 minus m square. Can I write like this? Because j is greater than equal to m, na? That's why j whole to j plus 1 minus m square is greater than equal to j m whole to m plus 1 minus m square. Which is what? This much is how much? If we calculate this one, we can write it as m square plus m minus m square. which is equal to what? Which is equal to m, isn't it? Which is equal to m. So we can conclude from here that that implies j whole into j plus 1, j whole into j plus 1 minus m square is greater than m, is greater than equal to m, right? It's greater than equal to 8. From which we can conclude easily what? Del jx into del jy, del jy is greater than equal to what? H cut square m by 2, isn't it? Because j whole to j plus 1 minus m square is greater than m, equal to m. So del jx and del jy would be what? Greater than equal to h cut square m by 2. Right? Which is what? This is what your, this is your eigenvalue of jz. Right? Eigenvalue of jz is what? Mh cut. So I can write them separately as what? Greater than equal to h cut into mh cut by 2. Okay. Mh cut is what? Mh cut is eigenvalue of what? Jz, isn't it? So I can write it as is mod of expectation value of jz, which was in the question. Okay. If you see the question, is there in the question? See. Okay. So yeah, this was the question. See how we approached the question. Okay. We have to write them everything slowly. We have to do this question type of questions very slowly. Okay. You don't need to rush in these type of questions. All right. Yeah. So if you have any doubt, you can ask me in the comment section. Okay. Next question is this. Find the. Let me just copy this one. Okay. Okay. This is the question. Find the energy levels of a particle which is free, except that it is constrained to move on the surface of a sphere of radius r. Right? It is moved surface of a sphere of radius r. Okay. So find the energy levels of a particle which is free except when it is constrained to move on the surface of a sphere of radius r. Okay. So this system what? System consists of a particle that is constrained to move. Okay. That is constrained to move on the surface of a sphere of radius r. All right, but free from the influence of what? Any other potential, isn't it? Which is free except that it is constrained to move on the surface of a sphere of radius r. That means we can say what? It is free from the influence of any other potential. So that is what? What is it called? It is called a rigid rotator. Okay. It is called a what? A rigid rotator. This is the concept of rigid rotator. Okay. Rigid rotator, what is it? Constrained to move on the surface of a sphere, but free from all other any kind of potential. Okay. Here what? Potential is zero. The energy of the system is what then? Energy is what? Hamiltonian is what? Kinetic energy plus potential energy. H is equal to T plus V. Right? H is equal to T plus V. So V is a zero. So T will be what? Sorry, Hamiltonian will be what? Only kinetic energy. Hamiltonian will be only kinetic energy, which is equal to what? L square, L square by 2y. Okay, for a rigid rotator, Hamiltonian of the rotator is what? L square by 2y. Alright, where I is a what? I is a moment of inertia. We're gonna moment of inertia is what? Mr square. Hmm. Mr square. So, how did we get to this? Can you tell me? H is equal to H is equal to what? P square by 2m. Alright, H is equal to P square by 2m. Now what will I do? See, I'll multiply r square and divide r square. 2m r square. Okay. Now what? rp whole square divided by 2m r square. Hmm? Now rp is what? R cross p is what? Your angular momentum. If I multiply r with any linear quantity, it becomes angular. Okay. So r cross p is angular momentum. So L square by 2 mr square. Mr square is what? I. So 2I. Got it? How I got this? H is equal to L square by 2I. Hmm. Yeah. So now H is equal to L square by 2I is there. So wave function of the system is what? Clearly independent of the radial degree of freedom, isn't it? Because it's constant. So the Schrodinger wave equation can be written as Schrodinger equation can be written as what? H H psi sorry Schrodinger equation can be written as H psi theta phi because it's independent of radial component. Theta phi is equal to L square by 2I L square by 2I psi because I put in place of H L square by 2I psi theta phi. Alright, psi theta phi, which is equal to what? E psi, H psi is equal to E psi, isn't it? H psi is equal to E psi. So I can write it as E psi theta phi. Hmm. E psi theta phi. Hmm. Now, so eigenstate of L square are the what? Spherical harmonics. Eigenstate of L square are what? Spherical harmonics. What are the spherical harmonics? YLM theta phi. Hmm. YLM theta phi. Alright. So corresponding energy values will be what? EL energy values. EL will be h cut square by 2I. It's also in atomic and molecular physics, isn't it? L1 to L plus 1, where L is your 0, 1, 2, 3, 4. So Schrodinger equation becomes what? Schrodinger's equation now becomes, if I put this value in place of energy, L square by 2I, okay, psi, sorry, y lm theta phi, ylm theta phi, okay, is equal to how much? Is equal to this one. I will put in place of energy E. This is H. It's H ylm is equal to E ylm. So is equal to h cut square by 2I, h cut square by 2I, A lower into L plus 1, A lower into L plus 1, Y, ylm theta phi, ylm theta phi. Alright. Now you can see this energy does not depend on the quantum number m. Okay, right? So that this means, what does it mean? It means that there are 2l plus 1 eigenvalues, isn't it? There are 2l plus 1 eigenvalues like yl minus l, yl minus l plus 1 I, okay, like that, corresponding to the what? Same energy. So the energy level el is what? So the energy level el is 2l plus 1 fold degenerate, isn't it? 2l plus 1 fold degenerate. This is the degeneracy of the energy state. Degenerate. Okay. Why? Why is it like this? This is due to the fact that the rotator's Hamiltonian, that is L square by 2I, commutes with L, isn't it? Okay. It commutes with L. That is, Hamiltonian is independent of the orientation of L in space because it commutes with L. Okay. Hence, the energy spectrum does not depend on the component of. Alright. Did you get it? So these were the What was the question again? Question was find the energy levels of a particle, which is this. So we got the energy level. This is the energy level h squared square by 2y L all into L plus 1. Alright, this was the Schrodinger equation using that. So we used spherical harmonics in this question. This was a question of what? A rigid rotator. Is it clear? Okay. It's a very conceptual question, so you have to practice again and again to understand this kind of question. Alright. If you have any doubt, you can ask me in the comment section. Okay, next question. Find the rotational energy levels of a diatomic molecule. Okay. Find the what? It's kind of a similar type of question. Find the rotational energy levels of a what? Diatomic molecule. Let me do this here only. Energy levels of a diatomic molecule. First, you take your 2 minutes and try this question out. Take your 2 minutes and try this question. Rotational energy levels of a diatomic molecules. Okay. First, what you have to do is two molecules you have to consider. Diatomic molecule, isn't it? Diatomic molecule. Two molecules will be what? M1 and M2. Okay, M1 and M2. What is the distance? The distance between them will be R. Okay, R vector. Okay, so let R1 and R2 be the distance of the center of mass. Okay, so what will be the one? M1 R1 will be what? Is equal to M2 R2. If R1 and R2 are what? They are distances from the center of mass. So the moment of inertia of the system will be what? Of the diatomic molecule, moment of inertia. M1 R1 square, M1 R1 square plus what? M2 R2 square, isn't it? The moment of inertia will be what? M1 R1 square plus M2 R2 square. This is a two mass system, so we can take it as mu R square. Okay, mu, where mu is what? Mu is a reduced mass. If there are two masses, the thing will be reduced mass. So M1 M2 divided by M1 plus M2. Alright, M1 divided by M1 plus M2. Alright, yeah. So we can say that, sorry, now angular momentum will be what? L is equal to L mod is equal to I omega, isn't it? L is equal to I omega. So mu R square omega. Mu R square omega. And Hamiltonian we can write now. Now we can write Hamiltonian is what? Hamiltonian is L square by 2i. We saw in the previous question how I derive the Hamiltonian as L square by 2i. Okay, you can do it again here. How to do it? Again, P square by 2m. Okay, P square by 2m. You multiply R square on both numerator and denominator. Okay, and from there RP is your L, so L square by 2i. Okay, so I is your mu r square here. It's not mr square. There was one particle there. Here two particles or two objects. So diatomic molecule. That's why 2 mu r square. All right, 2 mu r square. So I can write the eigenvalue equation as what? HLM. HLM. I can write as HLM is equal to L square by 2 mu r square Lm, isn't it? Because H is your what? L square by 2 mu r square, isn't it? So L square is how much? L whole into L plus 1, L whole into L plus 1, H cut square by 2 mu r square. We know this is your L square, right? Eigenvalue of L square is this much. Eigenvalue of L square is this one. Eigenvalue of Lz is what? ML H cut, isn't it? We have studied this one. Yeah. So this is your what? Lm. L is what? Orbital angular momentum. Alright? Yeah. So what is the degeneracy? Like the previous question, degeneracy will be what? 2L plus 1. Okay. And this will be what? Energy. Isn't it? This will be because we know H psi is equal to E psi. So your energy values will be what? This is our question. Energy values will be EL is equal to L whole into L plus 1. L whole into L plus 1. H cut square divided by 2 mu r square. All right. So these are the energy values, rotational energy levels of a what? Diatomic molecule. Correct? So the answer. Okay. Yeah. So yeah, this will be it for this class, and we have done like three, I think three questions, and they were very conceptual questions. So you keep practicing and try to do solve more questions. Okay. Yeah. So that'll be it for this class. We will do more questions in the upcoming lectures. Okay. Thank you. Thank you very much.